Today I'll be talking about the network interface layer of the TCP/IP protocol. This is a little bit different from the OSI protocol, but the TCP is the current standard. We're also going to be discussing what we call SLIP and the point-to-point in the TCP/IP. It can be used to set up connections between different types of computers. It operates and works independently of the operating systems. Therefore, a Linux computer can talk to a Mac computer can talk to a Windows, and all three can talk to each other. It does support a number of routing protocols, so it's not supporting only one. So any type of routing protocol that is set up can be used. It does enable the networking between organizations because it does only have 2 ports. And the nice part about this protocol is it is scalable. It does mean that it grows with the company's growth. And it can use a client-server architecture, which is great for a company. In the overview of the networking protocol, it is designed to provide implementation of the network stack from the network layer up, which is layers 3 through layer 7. The core protocols in TCP/IP run at layers 3 and 4 in the OSI model, which is known as the Internet layer, and the host-to-host transport layers in the TCP/IP model. Architectural models define network interface layer, which is the same as the data link layer in the OSI, or known as layer 2. However, the TCP/IP model does not use a data link layer. Those are provided through a WAN or LAN technologies. Layer 2 protocol is not always provided with TCP/IP. It's provided through serial connections and etc. This is where you enter with SLIP and PPP. Both of these were used to fill the gap between the IP stack and the physical connection, so between layer 3 and layer 1 of the TCP/IP protocol. SLIP is the Serial Line Internet Protocol. Although it was basically set up early in the 80s, it was never defined as a formal standard. However, because of its use and its wide use, it was known as the de facto standard since the 80s, before the RFC documents were initiated. In 1988, however, after the RFC was put out, it was decided to not be designated as the official standard, but to be designated as the non-official standard, which is kind of a colloquialism on terms. SLIP was originally set up as a stopgap when framing for datagrams was needed. And simply put, SLIP provides layer 2 framing services for IP datagrams only, nothing else. That's all it does, and it does a darn good job of doing it. So now we're going to discuss the basics of SLIP. It breaks down datagrams into bytes, and when it breaks it down into the bytes, it transmits 1 byte at a time. The last byte tells the receiving device it is the end, and this is what they call the SLIP end byte, and it has a binary value of 1, 1 with 6 zeros following. It is a very simple process. The beginning of the new SLIP also has an end character added for a failsafe, so that it always will make sure that there was an end process before, so it knows a new datagram is being sent. If for some reason the 1, 1 with 6 zeros, the binary value of 192, is being sent in the datagram, it also has the ability to use a special escape character if the value is equal to the end character. This way the receiver will go 1 more byte to determine what the value of that byte is. Here's an example figure that I found to show you how SLIP sends information or datagrams across. If you'll look, you'll see the upper layer sends it down to the IP, sends it to SLIP frame sends it across to the right, and transports it back up to the upper layers. This is kind of a summary of SLIP that I've put together. It breaks an IP into breaks an IP datagram into bytes or single digits. It does send an end character after the last byte of a datagram. If any byte in a datagram is 192, it replaces that 192 with a 219220 in the byte in the datagram. Unless 219 is in the datagram, then it uses 219221. What this does, it lets them know that that number needs to be either 220 or 221 or 192. Then if any byte is a 219, is replaced with the 219221 as I just said a moment ago. And I have a figure of this on the following slide as well. I have tried to put in some visual aids because this is, although pretty simple information, it's pretty hard to understand. Although this is easy to use, it doesn't provide many features. A standardized datagram size specifications. It does not provide error detection or correction mechanisms. It also does not provide any control messaging. It doesn't provide any type identification. It does not provide any address discovery methods or any compression support, as well as any security features. So, although it's easy to use, you can see that it is pretty basic. So, it's kind of one of those things that people don't like to use. So, hence, they came up with what they call PPP, or point-to-point. And again, this is where you're only using two devices. So, if you have device A and B, A talks to B and B talks to A, and those are the only two devices that will talk to each other. This is a robust data link connectivity using serial lines only. It includes many features that were not available on the SLIP version. It includes error detection. It does include compression, authentication, and encryption. It is a protocol, but it's considered a protocol suite because of everything that it does have to offer when compared to SLIP. So if you take a look at the difference, SLIP is kind of like your basic, let's use it as a vehicle analysis. SLIP is like your basic, no-frills, base vehicle that just gets you to work and back. And point-to-point protocol is kind of like your sports car, let's say like a Ferrari or a Lamborghini, that gets you there with style. It's much more robust than SLIP and is a protocol suite within a protocol suite, according to the authors. We're going to talk about the development and standardization of point-to-point. It was developed as a complete protocol suite when it was designed versus just a stopgap as SLIP was designed. It enables fully functioning layer 2 connectivity. And it did replace SLIP as the standard in 1990 through the RFC. It is a connection-oriented protocol, which means it is connected at all times. Another advantage is that it is synchronous and asynchronous capable, which means it can talk one way only, or it can talk both directions at the same time. And it can also talk in half duplex or full duplex capabilities. Like I said earlier, with connection A and connection B, it is a maximum of 2 connections, hence the reason it's called point-to-point. The advantages of point-to-point technology, or point-to-point, it's a more comprehensive framing when compared to SLIP. It allows multiple layer 3 protocols to be multiplexed on a single link, whereas SLIP you can only transmit one at a time. This can do multiple at one time, hence the asynchronous and the synchronous. It does have error detection for each frame by using a CRC code. It does negotiate link parameters, including the frame size, prior to transmitting. It is able to test the links prior to transmission to make sure that they are working, since we do have error detection, and it does support authentication to make sure that it gets where it's supposed to get to, and does support additional optional features that we're not going to discuss today, but there are quite a few of them. There are 3 main components to PPP, plus 2 extra. They have what they call the point-to-point encapsulation method, where it puts a header and a footer to encapsulate the message instead of sending 1 bit at a time. They call it the link control protocol, network control protocols, and the LCP support protocols and LCP optional feature protocols. The general operation of the PPP is that it sounds complicated but uses only 3 steps. These 3 steps are a link setup and configuration, link operation, link termination. And this is how it works. If you can take a look, you've got no link. Then on the right hand side, it's got link setup and configuration, link operation. Then again, it sends over to link termination. It is just a circle, and it continues to work. So the summary tonight. PPP was designed to allow it to be easily extended through the additions of protocols to the suite. And since PPP is a suite of many protocols, it makes sense that it is not defined as one singular standard. When researching the network layer, I knew this one would be difficult, as it was the layer where all the information was culminated to be transmitted through the network. I used many sources of information, including our textbook, to prepare this video, but did not think it would be as informative as it was when I first chose this layer. I hope that I have provided you with a greater knowledge of this network layer and how SLIP and point-to-point play a part in connecting your networks. Thank you for your time, and have a great day.